This video is going to discuss the complement rule. First, we're going to define it. If A is an event, the complement of A is the event that A does not occur. The complement of A is denoted as A complement. There are other options for that. We can use A prime or not A. This textbook is using A complement. Couple of things that we need to get out of the way and define also is first, either A or A complement must occur. For example, it must either rain or not rain. The second thing, A and A complement are mutually exclusive. They cannot both occur. For example, it is impossible for it to both rain and not rain. Now, there's a few things that we need to define in order to make this a little clearer. You will see in problems that involve complement these certain words. For example, you might see something like more than 200, or we can say more than 90. What that means is we're looking at greater than 90, and if X represents our event, X is greater than 90. Notice that I'm using A as the event, but I'm using X to define the more than. There's also the statement at least. When you see at least 90, what we're talking about is that we're going to start at 90 and X will be greater than or equal to 90. Remember, 90 is at the bottom, at least. It could be more than that. It could be 91, it could be 97, it could be 1,495,000. But it has to be at least 90, so X is greater than or equal to 90. The next one that we'll look at is fewer than. I'm going to go ahead and continue to use 90, so fewer than 90. That means my event X is going to be less than 90. And then finally, we're going to talk about at most. So at most, 90 means that 90 is the maximum. It could be 90, but it's going to be less than that. Maybe it could be 89, it could be 22. So we'll write that as X less than or equal to 90. And these are going to allow us to be able to find the complements of our statements. For example, if I wanted to look at the complement of more than 90, that's going to be 90 or fewer. Or I could say at most 90, which would mean X is less than or equal to 90. So here's an alternative way of saying at most 90, 90 or fewer. Now, let's go ahead and do some problems so that we can fully understand how to determine complements. Okay, a sample of 225 internet users was selected. State the complement of each event. Number one, more than 200 of them use Google as their primary search engine. Now, let's go back up here. You'll notice right here the more than, which means X is greater than 90. And I said that a complement would be 90 or fewer, or we could state at most 90. They mean the same thing. Now, depending on how your textbook wants you to word it, it could cause issues, but generally speaking, what you can do is simply say if more than 200 of them use Google as their primary search engine, the complement would be 200 or fewer, or at most 200. Either one of those use Google as their primary search engine. So now let's look at the next one. It says at least 200 of them use Google as their primary search engine, which means that if our event is X, at least 200 of them is going to be X is greater than or equal to 200. So the complement would be X is less than 200. So then we could say less than 200 of them use Google, or we could come up here and say fewer than 200 use Google. And I'm just going to go ahead and write an ellipse here, meaning Google as their primary search engine. Now let's look at number 3. Fewer than 200 of them use Google as their primary search engine, which means at least 200 of them use Google as their primary search engine. So what you'll notice is that 2 and 3 are actually complements of each other. Yeah. And then finally, number 4, exactly 200 of them use Google as their primary search engine. Now, we didn't talk about exactly previously. I was saving it for this one. So if exactly 200 is my event, X equals 200, the complement of that will be that X cannot equal or will not equal 200. So then I can simply say the number that used Google as their primary search engine is not equal to 200. Okay, we're going to do a few more. So a sample of 700 cell phone batteries was selected. We're going to go ahead and find the complement of each one of these statements. The first statement, exactly 24 of the batteries were defective, i.e., X equals 24, means that the number of defective batteries was not equal to 24. And so we'll go ahead and we'll look at the next statement, which states at least 24 of the batteries were defective. Well, at least 24 means that 24 or more, so X is greater than or equal to 24, and the complement will be less than 24 of the batteries were defective. The next statement says more than 24 of the batteries were defective. So that means more than, there's no equal in here, so it's going to be simply X greater than 24. The complement will be X less than or equal to 24, which is at most. So we can write it at most 24 of the batteries were defective. Now, I could have written it as simply 24 or less of the batteries were defective, but to me, at most is a more concise way of stating it. And then finally, fewer than 24 of the batteries were defective. So that's a X less than 24, which means that the complement of that will be X greater than or equal to 24, or at least 24 of the batteries were defective. And that's simply the complement rule. Now, if we're going to talk about probabilities concerning the complement rule, so the complement occurs when the event doesn't occur. If an event does not occur, then its complement occurs. if an event occurs, then its complement does not occur. And what we're going to do is we're going to put this into probability notation, which means that the probability that A or a complement occurs must be equal to 1, because one or the other will occur. And what we're going to do is we're going to take this and we are going to put this into the addition rule for mutually exclusive events, remembering that the probability of A or AC, now remember when we say or, we can use the fact that they are mutually exclusive, and what that's going to be equal to is the probability that A occurs plus the probability that a complement occurs, its complement. In other words, if I add the probability of A occurring to the probability of a complement occurring, that's going to be equal to 1. And you'll notice how this statement flows and generates this statement. Now, what that means is I now have a formula for finding the probability of A complement, given that I know what the probability of A is. The probability of A complement will be equal to 1 minus the probability of A. And we're going to use that to help find probabilities when we know the probability of either the event or the probability of the complement of the event occurring. Because if it's a probability distribution and they are mutually exclusive events, I know that the sum of the probabilities has to be equal to 1. And since we're only talking about 2 events here, it's relatively easy to calculate these. This is what we call the rule of complements. Okay, so let's look at this problem. According to the Wall Street Journal, 40% of cars sold in a recent year were small cars. What is the probability that a randomly chosen car sold in that year is not a small car? Well, noting that our event is not a small car and small car, those are our 2 events, we can look at it and simply state that the probability that the car sold is not a small car is going to be equal to 1 minus the probability that it is a small car. Now, since we know that the probability is 40% for the fact that it was a small car sold in a recent year, that's going to be 1 minus 40%, but we know we can't physically subtract 40%, so that's going to be 1 minus 0.40, which will yield 0.60 or 60%.